I'm Pete Zielinski with Modern Machine Shop Magazine, and I am here with Dr. Julius Shoup, machining expert at TechSolve. And we're going to talk about coatings. Coatings, the thing that gives your cutting tool this elegant color. Julius, why do we coat tools? What is the coating doing in machining?
I like to think that there's three main effects that these coatings have. I think there's wear resistance that's offered because the coating is harder. There's a thermal barrier, and then there's lubricity, which can help act kind of like a lubricant if you're cutting dry.
Okay, so these terms I mentioned, PVD, CVD, what do they mean?
Well, PVD stands for physical vapor deposition, and PVD coatings can be applied in a line-of-sight process that allows you to coat very sharp edges. Now, CVD stands for chemical vapor deposition, and this chemical vapor requires much higher temperatures, and even though you're not limited to line of sight, you need to apply the coating much thicker.
So let's just skip ahead to the main takeaway. How should we think about PVD versus CVD and where these different types of coatings apply?
Yeah, absolutely. The PVD coatings, because they are thinner, they are generally applied to more finishing type tools because you can get a sharper cutting edge. The CVD coatings are thicker and they provide a better thermal barrier, so they're actually better for roughing a lot of times.
We actually have machining footage to illustrate this. Here are roughing passes. Here is an uncoated tool. Here is a PVD coated tool. And here is a CVD coated tool. Julius, in these roughing passes, what have we seen?
Well, I think what we saw right away was that the uncoated tool did significantly worse than either of the PVD or CVD tools. And this goes back to the fact that the coating on both the PVD and CVD provided a level of protection and a level of lubrication that really helped them perform very well in this dry process. The uncoated tool didn't have any of that protection, and so it failed prematurely even before completing a single pass. Now, between PVD and CVD, I think the differences are maybe slightly more subtle, but we could definitely see a lot more vibration with the PVD tool in this cut. And that goes back to the sharper cutting edge. This sharper edge and the more positive geometry of the PVD tool led it to perform much more like a chisel being pushed over some hard material rather than a rake being pulled over sand.
So let's look at those cutting edges. Here is the uncoated tool. Here is the PVD coated tool. Here's the CVD coated tool.
I think the uncoated tool had catastrophic failure, which is because the lack of lubrication and thermal barrier on the rake face caused the chip to dig into the tool, which is what we call crater wear. And this actually weakened the edge to the point that it actually broke out. If we look at the PVD tool, we see a similar pattern, but it's much less pronounced. And then in the CVD, we can see very little crater wear, which actually led to the much more stable wear pattern of the CVD tool.
That was roughing. Let's take a look at finishing. Same tools, same passes, except they're finishing cuts now. Here is the uncoated tool. Here's the PVD coated tool. Here's the CVD coated tool.
Yeah, I think it was interesting how the same patterns that we saw in roughing showed up again in finishing, but maybe in a slightly different way and from a different angle. So the uncoated tool, it started out pretty well, but it just couldn't last through even a single cut, which tells me that for dry machining, we really want to have a coating. Now, between PVD and CVD, remember that I said that the PVD coating is actually slightly sharper? Well, I think we saw that this sharpness is actually a big advantage in finishing. Not only are we generating lower cutting forces, but at the same time, we're also able to break the chip because of the more positive geometry.
Here are the cutting edges. Here's the uncoated tool. Here is the PVD coated tool. Here's the CVD coated tool.
I would say that the uncoated tool clearly has much more wear than the other two tools had. And this is because the absence of a coating, the lack of lubrication in dry machining caused the workpiece material to erode the tool much more rapidly as a combination of increased heat and less lubrication. The sharper PVD tool definitely did much better in the actual process because it was able to break the chip. So I think the edge in this case, no pun intended, goes to the PVD tool.
So tie a bow around all this. How should we think about PVD and CVD, where they fit in?
Well, Pete, I would say in summary, think of CVD for roughing and PVD for finishing.